All right. Welcome to our first day, of online learning. So, what we are going to do today is just kind of review what we did last Friday. So, there were a significant amount of people absent, and based on some questions that I got either at the end of class or over the weekend, before we move on to the next lesson, I'm just going to kind of recap what we did. I added some examples that were kind of like a couple on the homework, like these two, the main ones that I got questions about. And then after I finished grading your chapter 7 test, I definitely feel like we need a little bit more practice with simplifying the radicals. So we're going to do that before we move to the rest of this unit. Okay. And so like I mentioned in class on Friday, it's going to be a learning curve for everyone. So we're just going to see how this kind of model works out, and then we'll change and adapt if necessary. Okay. All right. So before we get to a couple of these examples, I actually want to start with the simplifying each radical expression. So I kind of put a couple just basic radicals and then some where we have to square it. And then this is something called rationalizing the denominator, which is something we're going to have to do as we progress during the rest of this unit. All right, so remember my first suggestion when you have a number, especially one that you're maybe not as familiar with, when you type that into your calculator, always start by just saying, okay, is the square root of 150 going to be a whole number? No, it's not. So then we're going to say, okay, let's do that up here. I'm going to write the list of perfect squares from 4 to maybe like 144. So we'll go up to 12 squared. So we've got 4, 9, 16, 25, 36, 49. Let's see, that's 7. So this would be 8, 9, 10, 11, and 12. Okay. So you guys, a lot of people learn like we're going to make a factor tree. We're going to list it underneath as prime factorization or kind of make your tree all the way down. And a lot of times that is just a lot of work. And then there's all these numbers at the end that we just don't fully understand. So the way I like to do it is just focus on these numbers. Okay. Do any of these perfect squares go into this value under the radical? That way you're kind of limiting your options. So when I see 150, the 25 is what jumps out to me. So I'm going to say, all right, well, what's 150 divided by 25? 6. So I can break this down to 25 and 6. There is not another perfect square that goes into 6. So that means that 6 cannot be simplified. It has to stay under the radical. And then the square root of 25 is 5. And so that would be my answer. Okay. So now I go to the 200. Again, I see the 25, but if we do 200 divided by 25, we get 8. So when I ask myself that same question, is there a perfect square that goes into 8? It would be 4. So that just means that while 25 does go into 200, it's not the biggest perfect square. So then I kind of keep looking past 25 and I see that 100 right there. So I can break that down into 102. And then the square root of 100 is 10. And then I've got that 2 left under the radical. So you're always looking for the biggest perfect square. Okay. So then I go to 32. Think about my factors that go into 32. 4 goes into 32 8 times, but 4 also goes into 8. So that means that's not the biggest one. So I'm going to go 9. 16 goes into 32 2 times. So that's the biggest perfect square. So that means the 2 stays underneath. Square root of 16 is 4. Okay. All right. And so for number 4 then, 4, 5, and 6 are more like operational. So when you are taking the square root of a number and squaring it, square rooting and squaring are called inverse operations of each other, right? If I had an equation that was like x squared equals 20, to solve that, because x is being squared, we would take the square root of each side. right? So whenever you're squaring a radical, they cancel each other out, leaving us with just 150. That would be our answer. Okay. Now I want to show you for number 5, like the actual mathematical way to do it, but then you are always welcome to use your calculator on these. So if you're not 100% confident, then just type it into your calculator and I'll show you that too. All right, so now we're squaring this radical that has both something underneath and something on the outside. So 2 radical 3. So when you square something, you are really multiplying it by itself. And so whenever you multiply radicals like this, you always multiply like the like parts. And so 2 times 2 is 4. And then we would have the square root of 9 underneath. Well, the square root of 9 is 3. And so this would be 12. And so when we type that into our calculator, you can really just type in 2 radical 3 times 2 radical 3. Just make sure you close the parentheses after that. You still get 12. So if you're not 100% sure, just type it into your calculator. Okay. All right, this last example then is something called rationalizing the denominator. So it's not 100% simplified to have a radical in the denominator. I'll explain more about that in a lesson video a couple days from now. I just want to keep this one kind of as basic as I can. And so what you want to do to rationalize a denominator is think about what we would need to do kind of in this situation to kind of undo the radical. And so we saw here, well, when I multiply a radical by itself, it creates a perfect square that now I can take the square root of. So that's what we want to do whenever we are rationalizing a denominator, trying to get rid of it down here. In order for me to turn that into a perfect square, I would need to multiply radical 3 by radical 3 so that I could get radical 9. And then just like when you're trying to get common denominators in like an addition or subtraction problem with fractions, whatever you do in the numerator, you have to do in the denominator to keep that value equivalent. So now my numerator would be 4 radical 3, and then radical 3 times radical 3 is radical 9. Square root of 9 is 3. So that now gets rid of the denominator or the radical in the denominator. Okay. All right. And so we will kind of touch base more on like 4, 5, and 6 as needed. Again, I just kind of wanted to give you guys a basic intro here. So now we're going to review the trig part of last week's lesson. So I put one example of kind of each type of scenario. In number 1, we were given 2 sides, no angles other than the fact that this is a right angle. And in this one, we were only given 1 side and 1 other angle. So our approaches are going to be a little bit different. So in number 1, since we know 2 out of the 3 sides, we will start by using the Pythagorean theorem to find that 3rd side. So we don't have to do any trig yet. All right, so a quick review about the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay. A and b are always the 2 legs. C is always the hypotenuse. So it just happens in this one that the hypotenuse is the side that you don't know. But if we didn't know this side, for example, then my variable would be either the A or the B. And it doesn't matter which leg you call A and B as long as those are the 2 legs. And so our approach to solving would be a little bit different. All right, so I'm going to start by plugging in 8 squared plus 4 squared equals c squared. So that would be 8, so 64 plus 16 is 80. Okay, and we're going to round all these answers to the nearest tenth. Now, when we're solving the right triangles using like trig and the Pythagorean theorem, As of now, we are going to just round to everything to the nearest 10. So I'm not going to require at this point that you simplify and rationalize the denominators. We will focus more on that when we get to 8.2. So remember, we are working backwards this unit. Right now, I'm just kind of checking that you can get these basics done. All right, so now we would take the square root of 80, which is about 8.9. So C is going to be 8.9. So over here, I just put all of the angles and sides in this triangle. So some of these we already know. So now that I found that last side, so AB was the C that I didn't know, so that's going to be 8.9. AC is 4, BC is 8. We don't know AB, but we know that angle C is 90 degrees. All right, so now we need to find these two angles. And this is where the trig comes in. So we're going to first pick either angle A or B to find. I'm just going to pick angle B in this case. So we learned about these three ratios on Friday: sine, cosine, and tangent. And we use the acronym SOHCAHTOA to help us figure out the ratios. So sine is the ratio of opposite over hypotenuse. Cosine is the ratio of adjacent over hypotenuse. Tangent is the ratio of opposite over adjacent. So what I'm going to do now is I'm going to go back to angle B, and I'm going to label the two sides that I was given based on angle B. So this 4 here is the opposite side, and the 8 would be the adjacent side. So then we go back up to our trig ratios and ask ourselves, okay, well, which one of these three trig ratios incorporates opposite and adjacent? Sine doesn't, because that has the hypotenuse. Cosine doesn't, because that has the hypotenuse. So that is how I know to choose tangent. So my equation would be the tangent of angle B is equal to 4 over 8. Remember, this is always an angle measure, whether we know it or not. And so now this is one quantity. So we need to figure out a way to undo that. And we always do, like here, inverse operations to get that variable that we're looking for. So if I wanted C and it was being squared, I took the square root. So if I want B and I'm taking the tangent of that, I need to take what's called the inverse tangent of both sides. So now that undoes this over here, and I'm left just with B equals the inverse tangent of 4 over 8, which you can simplify to 1/2, but you don't have to, because the 4 over 8 is not going to be our final answer. So we've got our three trig ratios right here: sine, cosine, tangent. So now I'm going to hit the second tangent to make sure that I'm taking the inverse of 4 divided by 8. And I get measure of angle B to be about 26.6 degrees. Okay. And now the good thing about this is once we've got one of those two acute angles, we can now just say, all right, if I know 2 out of these 3 angles, I can just take 180 minus 26.6 minus 90, and I get 63.4 degrees. Okay. And so that found all these missing measures here. So now we're going to look at this other case right here. So we've got this triangle. Now we know only one side, and we do know one of the other 2 angles. So I can start by saying, okay, so the measure of angle R is 90 degrees. That's my right angle. Oh, Q got cut off here. The measure of angle Q is 53 degrees. I don't know the measure of angle P yet, and I know PQ is 30. So now I'm left to find these 3 things. Okay, so like here, when we knew 2 out of the 3 sides, we pulled in information that we had already known to find the other missing side. Now we know 2 out of the 3 angles, so we can easily find that third by subtracting both from 180. So the measure of angle P is going to be 37 degrees. Okay. So I'm going to take a similar approach as I did when I was finding angle B in number 1. Always start, this time though I'm not going to pick, because I always want to use the angle that I was given, just in case I made a mistake finding that one. That way I'm not using a wrong angle to find what I am looking for. And so now I'm going to label the sides of my triangle based on that angle Q right there. So this side over here would be the opposite. The 30 is the hypotenuse. That's always across from the right angle. And that leaves P to be the adjacent side. Okay, so I'm solving for P and Q. I know the hypotenuse. So if I want to set up two separate trig ratios, if I know the hypotenuse, that means I'm going to use sine and cosine because those are the two that have the hypotenuse in them. So then the opposite side would be my variable here. The adjacent side would be my variable here. So I'm going to set up two separate trig ratios to get those two sides. So I will do sine first. So the sine of 53 is equal to Q over 30. And then cosine of 53 is equal to P over 30. So sine opposite over hypotenuse, cosine adjacent over hypotenuse. Regardless of where your variable is, you always start by undoing that fraction. So I'm going to multiply both sides by 30 here. Multiply by 30, multiply by 30. Luckily, now that gets the variable by itself. So my answer here is just going to be Q equals, and then 30 times the sine of 53, which is going to be, that's going to round to 24, because that 5 will bump that 9 up, which bumps that up to the nearest whole number. Okay, and Q is PR. So I'm going to go ahead and fill that in over here. And then 30 times the cosine of 53 is going to be 18.1. Okay. And so those would be all the missing sides and angles there. Okay. All right, so now I want to take a look at a couple examples that were on your homework that I got a lot of questions about. First of all, where it says on your homework, it says find the other 6. I apologize. It should say 2. I adapted that worksheet from an old assignment and when we talk about the reciprocals, which you guys do not have to worry about. So you only have to find the other 2. So for example, this one I was given sine. So that means I want to find cosine and tangent, which are just reciprocals. Now I'm not solving for an angle here. The trig ratios are just a ratio, comparison of two numbers. So in this one, if I'm given tangent, that means I want to know sine theta and cosine theta. And my answers to both of these will just be the fractions. But what I need is that third side. So if I draw this triangle right here, and I just put X as one of my acute angles, right? Because remember, the trig ratios are only for the acute angles, not the right angle. And so then if I think, well, what is sine? Sine is opposite over hypotenuse. And so if this is where I put my angle, and again, you're going to get the exact same answer if you put X here. It does not matter because the ratio is the same. The opposite side would be this one. So that means that this side has a length of 3. This is the hypotenuse, so that means that has a length of 4 or 5. So what I have to do now before I can find cosine and tangent is find that missing side using the Pythagorean theorem. So I'm actually going to erase that so I can have a little bit more room to solve this. So now this is the side I'm looking for. This is one of the legs. This is the hypotenuse. So when I plug this into the Pythagorean theorem, I may use a as my variable. A squared plus 3 squared equals 5 squared. So remember, the hypotenuse always has to be C. And so then if I simplify that, a squared plus 9 equals 25. Subtract 9, I get 16. Sorry, you can hear our washing machine in the background. And then when I take the square root of each side, square root of 16 is 4. So that means that this missing side is 4. So when I go to find the other two trig ratios, cosine is adjacent over hypotenuse, and that would be your answer. Tangent is opposite over adjacent. So you're not actually finding any angles. When it specifically says find the trig ratio, you are just finding this ratio, this fraction, this relationship between the two sides. Okay. So if I go to this next one here, I'm going to erase this, move this over. I'm going to go ahead and I'm going to label my sides again, draw my right triangle. So theta I'll put right here, doesn't matter what angle you use. Tangent is opposite over adjacent. So if my ratio is 8 over 5, then I'd put opposite over adjacent. And so now what I'm going to do is find the hypotenuse. That's the side I need in sine and cosine. So now my equation, that is my variable. So 5 squared plus 8 squared equals c squared. 25 plus 64 is 89. And so when I take the square root, I get about 9.4. Remember, I'm okay with you guys doing decimals at this point. We'll fine-tune the radical stuff later on this unit. And so now I can put that here. And so when I find my other two trig ratios, sine of theta is going to be opposite over hypotenuse, and cosine would be adjacent over hypotenuse. Okay. Again, when it says just find the trig ratio, you're not finding an angle. That would specifically say find an angle. All right, so there's our first lesson. You will hopefully be watching this on Tuesday, March 17th, which just happens to be St. Patrick's Day. So if you would like a bonus point added to your quiz later this week, when you submit this assignment, if you snap a fun selfie of yourself wearing green, working on your math homework, or eating something Irish. My grandma's from Ireland, so we ate a lot of Irish food growing up. I will give you a bonus point on your quiz. So thank you for watching this, and just look for a Canvas message from me with more detail about what's coming up.